Okay, let's have a look at which one is this one? This is 1904. All right, so this is 1904, and we're going to have a look at number 9. I'm just going to change the brightness of it a little bit. Let's see if I can make it so it works a little bit better. So this is number 9, and it says Ryan uses a calculator to work out the size of each interior angle of a regular heptagon. Now, a regular heptagon is 7 sides, and it says he answers, it's a 2DP, writes down 128.57. So how does he get that? Well, first of all, we've got an equation. The equation basically says the internal angle of a heptagon, here we go. So the internal angle of a heptagon, or the internal angle of anything, any regular polygon, is going to be n minus 2 times 180 divided by n. So we've got n, which in this case is 7, it's a heptagon. We're going to subtract 2, multiply by 180, and divide by 7. And we can simplify this as we go if we want, but I'm just going to pop the whole thing into a calculator. Here we go, and just do the whole thing in one go. So it's going to be 7 minus 2, which is 5. So I'm going to have, I'll write out 7 minus 2, here we go. 7 minus 2 times 180. And I'm going to divide the whole thing by 7. And it doesn't really matter if I put brackets anywhere in particular. There it is, 128.5714. I'm going to write 128.5714. And this, of course, is in degrees. Now, what the question says, though, is he writes his answer to 2DP and writes down 127.57. How does that work? Well, if we have a look at the answer and we say, right, well, here's 2DP, here's the decimal place, let's do 2DP's 1, 2. So we cut it off at this point. We look at this number here and we say, is this number 5 or more? The answer is no. So we leave everything unchanged. If this was a 5 or more, like a 5 or 6 or 7 or something, then we would still cut it off here, but we would make the 7 1 bigger. So it would be, in this case, 128.58. So the answer is 128.57 degrees, and I can put here 2 dp. And there is my answer. Now the next part, though, says, well, write down the size of each interior angle of a regular heptagon as a mixed number. So the same thing is true as before. We've still got the same equation, but this time I'm going to not solve it. I'm going to make it into a mixed number. So we've got the internal angle, so I'll just write internal angle, in this case of a heptagon, is n minus 2 times 180 all over n. That needs to be in brackets. All right, so, and if it wasn't in brackets, we'd end up getting the negative 2 multiplied by the 180 first, and we don't want that. So let's fill this out as best we can. So this becomes a 7 minus 2 times 180 divided by 7. This time, though, I'm going to actually solve the bracket. 7 minus 2 is 5. We've got 5 times 180 over 7. Now, 5 times 180 is actually 900. So let's have a look at that just to make sure that sounds about right. 5 times 180 is, yeah, it is. It's 900. That's fine. Let's get that 900 down. So there it's 900 over 7. Now, that doesn't actually simplify particularly well. So what we would need to do to turn that into a mixed number, and seeing as this is year 10, you can, of course, use a calculator to do this. So the question really is, how many times does 7 go into 900? And then what would we have left over? So you can either do this manually. On the calculator, by the way, you can do this very, very easily. You can just go 900, so 900, and I'm going to use the over button. So I've got 900, I'm going to push this button here. 900 over, there it is, and I'm going to push 7. Is 900 over 7. And then to find out what that is as a mixed number, I can just push this button here. So I'm going to push the shift button and the button which says ABCD equals D over C. And I get 128 and 4/7. So that equals 128 and 4/7. Now, the way to do that otherwise, if you didn't have the calculator, you simply divide 7 into 900 and then ask yourself, so you go 7 into 900 and say, well, how many 7s go to 9? Well, there's 1 7 in 9. Any remainder? Sure, there's 2 remainders, so I'll put the 2 over here. How many 7s are there in 20? Well, there's 2 7s in 20, but 2 7s are 14, so we have 6 remainder. So I'll put 6 here. How many 7s in 60? Well, 7 8s are 56. 56, but we have 4 left over. So I could either keep going by putting a decimal place here, a decimal place here, and bring down the next 0. I'm not going to do it. I'm just going to put it very, very lightly here. And that 4 remainder I'm going to put here. And then I can say, well, how many 7s are going to 40 and keep going. But we're not going to do that. We're going to say, well, that 4 becomes the numerator. So it's 128. 7 goes into 900. 128 and 4. There's no decimal place here. I'll scrub that out. 4 over 7. And that's the answer. That's how you'd find the answer. So that's that decimal place, by the way, which I scrubbed out. I'm actually going to rub that out because I don't like that at all. That's not good at all. Here we go. Let's get rid of that. There it is, 128. Let's make that 8 into an 8 again. Got rid of half of it. There you go. 128 and 4/7. Hope that's better. Good. Thank you, folks. Good question, by the way.